Your refrigerator is the only appliance in your house that runs every minute of every day. It never turns off. And right now, it is running 15 to 25% harder than it needs to because of something that takes 7 minutes and $4 to fix. Behind the toe kick panel at the bottom of your refrigerator, or in some models at the back, there is a condenser coil. Wrapped around that coil are aluminum fins, thin metal plates spaced 10 to 20 per inch, that allow air to flow through and carry heat away from the refrigerant. If those fins are bent, and in most refrigerators more than 3 years old, they are, airflow through the condenser drops by 20 to 40%. When airflow drops, condensing temperature rises. When condensing temperature rises, your compressor runs longer and hotter on every cycle. You pay for that every month on your electricity bill. GE's own 1954 refrigeration service training manual listed fin straightening as a quarterly maintenance item. The instruction was removed from consumer documentation in 1962. I'll tell you why at the 7-minute mark. Stay with me. A standard residential refrigerator consumes 400 to 800 kilowatt hours per year, depending on size and age. At the U.S. average electricity rate of $0.17 per kilowatt hour, $68 to $136 per year to run your refrigerator. A 30% reduction in condenser airflow, typical for a 5-year-old refrigerator with no maintenance, increases compressor runtime by 15 to 25%. On a 600 kilowatt-hour annual baseline, that is 90 to 150 kilowatt-hours of wasted electricity. $15.30 to $25.50 per year from a mid-efficiency unit. On an older high-consumption model, $47 to $67 per year wasted. Appliance repair service call to clean and straighten coils, $89 to $150. The technician's tool, a fin comb. The fin comb costs $4 at any HVAC supply store or online. Time to use it? 7 minutes. Technician time on this specific task?
4 minutes.
Yeah, 4 minutes, that should do it. Their charge, $89 minimum. That is $22.25 per minute for sliding a $4 plastic comb through aluminum fins. Here is the thermodynamics and why fin geometry is not cosmetic. The vapor compression refrigeration cycle works in 4 stages. In the condenser, hot, high-pressure refrigerant vapor gives up heat to the surrounding air and condenses to liquid. The rate of heat rejection from the condenser depends on the temperature difference between refrigerant and air, surface area of the coil, and airflow rate through the fins. Condenser fins exist to maximize surface area. A coil with 15 fins per inch has 15 times the heat transfer area of bare copper tubing. When fins are bent and pressing against each other, effective airflow passages collapse. The areas between fins where air must flow narrow from the design specification of 0.067 inches to air resistance increases as the inverse square of the passage width. Halve the width, quadruple the resistance. With reduced airflow, condensing temperature rises. The refrigerant must reject the same heat into less airflow. Every 10 degrees Fahrenheit rise in condensing temperature reduces the coefficient of performance, the efficiency ratio, by approximately 3 to 5%. A refrigerator running 118 degrees to condensing temperature instead of the design 95 degrees is operating at 7 to 12%. Compressor wear also accelerates. High condensing temperature means higher head pressure. Higher head pressure increases compressor motor current draw and operating temperature, reducing compressor lifespan by an estimated 20 to 35% per the Refrigeration Service Engineers Society 2019 Technical Bulletin. Right now you might be thinking, if this is a real problem, why doesn't my refrigerator manual mention it? Because it did, until it didn't. The economics made the decision for that too. Stop. 423 million. That is the estimated number of refrigerators currently operating in U.S. homes, including second units in garages and basements. Per the Energy Information Administration 2023 Residential Energy Consumption Survey. Public data, searchable. If 60% of those have condenser fins bent enough to cause measurable efficiency loss, a conservative estimate based on appliance technician survey data, that is 253 million refrigerators wasting electricity right now. Combined waste. Approximately 8.4 billion per year in unnecessary electricity consumption. For want of a $4 plastic comb. The General Electric 1954 Refrigeration Serviceman's Handbook, available in trade archives, includes in its quarterly preventive maintenance checklist. Item 3. Inspect and straighten condenser coil fins using approved fin comb. Bent fins reduce condenser airflow and shorten compressor service life. This was not fringe advice. It was GE's own standard. In 1962, GE launched the GE Service Contract Program nationally, a subscription maintenance service sold to consumers through appliance dealers. The service contract required annual technician visits. The quarterly consumer maintenance items, including fin straightening, were quietly removed from the Consumer Owner's Manual distributed with new refrigerators. The service contract made those tasks billable again. The instruction to straighten your own fins was not lost. It was removed. Here's how deep that goes. Check the warranty documentation that came with your refrigerator. Most major brands, GE, Whirlpool, LG, Samsung, include language stating that unauthorized disassembly, modification, or repair of sealed system components voids the warranty. The condenser coil assembly, including the fins, is technically a sealed system component in most warranty definitions. The toe kick panel access cover is considered a service access point. A fin comb inserted between condenser fins is, by warranty definition in most documents, unauthorized modification of a sealed system component. The instruction GE published as mandatory quarterly maintenance in 1954 is now warranty voiding in 2024. The same manufacturer that told service technicians to straighten fins quarterly now tells consumers that touching the fins voids their warranty. Nobody changed the physics. They changed the document. They changed the document. Silicon Decay reality check. Fin combing works on aluminum fin arrays, which covers most refrigerators made since 1970. Some modern refrigerators use microchannel condensers, where fins are much smaller and less accessible. If your condenser is a flat microchannel type and the fins are bent, A fin comb will not reach them effectively.